Okay, here's our second example for graphing tangent. And let's just get right to business here. As it looks like we have a negative sign out in front here. And it's a -1. So the way that we want to operate with this is that we know it's negative, so we know it's going to be flipped. Okay, and when I say flipped, it's going to be flipped over the x-axis, and it is 1. It's a -1, so that means is that it's going to be flipped and regular. Okay, so if it were like a -2, it would be flipped and narrower rather than regular and whatnot. Okay, so we just kind of put that information off to the side, and then we work with the rest of what we got. All right, so let's take a look at the period of this thing. So what we do is that we take this number, which is b, and we are going to divide that into pi. So we got 3/2 divided into pi, which is going to be 2 pi over 3. All right. So the period is 2/3 pi. Now this is the way that we want to play that out. So 2/3 pi basically means is that, you know, that's like 1/3 plus 1/3. And the reason why that's important is because it looks like in order to set up what I'm going to do next is that I have to go 1/3 pi in this direction and 1/3 pi in this direction, and that is going to give me the asymptotes that I need, or the, you know, where tangent is going to start to repeat itself in between each asymptote. So it's important to have those set up correctly and to to basically portion it out in between the y-axis like that. Okay, so far so good. And what we need to do is that we need to get the phase shift then. And the phase shift is going to be the same thing. It's going to be c over b, which means is that we have to take a look here first. We know it's positive, so we know it's going to go to the left here, and we got to go pi over 4 divided by 3/2, which is going to give me pi over 4. I flip and multiply the second part, or the denominator there, which is going to give me 2/3. And it looks like this, just doing some calculations here. Not too difficult. And we get pi over 6 to the left. All right, and so looks like I'm going pi over 6 to the left. So that means is that each one of these are going to jump on over to the left that much. And from there, we can continue the patterns that we need to answer the next questions and finish up the rest of the graphs. Okay, and this one right here doesn't have a vertical shift. You don't see too many vertical shifts with tangent there, and so there is going to be none. And let me clean up the graph and repeat out, or show you how to go ahead and use patterns to repeat the rest of the graph, and then we can answer the rest of the questions. Okay, so it looks like there's going to be, 2 spaces in between each x-intercept and each asymptote. So it looks like I'm going to be switching those on and off like this for good measure. And there we go. And it says that it's going to be flipped and regular. So that means I know, and I don't want you guys to mark this down right away, but it's going to look something like this. Okay, we just need to get maybe some of the y-intercept so we can kind of see what that physique really entails, and then scope our graph after that. Okay, so x-intercepts. We go to the first positive x-intercept, and we go, all right, that's going to be pi over 2 plus, and let's go ahead and see what is the distance going to be in between each one of these guys. And so I can do a little bit of math, or a little bit of arithmetic over here. Say pi over 6 minus pi over 2 is going to give me, and so we can get some common denominators here, where we would have 7 pi over 6 minus, and that would be what? Top and the bottom, multiply 3 and so that is going to give me 3 pi over 6, and so that's going to give me, let's see, 4 pi over 6, which is going to give me 2 pi over 3. Yay. And so we have 2 pi over 3 n, okay, and then where n is an integer, comma 0, okay? So we know that distance in between them is going to be 2 pi over 3 each time. Now, something that we could probably put in our back pocket as well is that we're not there yet for the domain, but that means is that the domain is going to be the 2, oops, I wrote that wrong, 2 pi over 3 as well, okay? Because it's, you know, since it's a function that's periodic, it means that it's going to repeat itself. And so we can take advantage of those facts just to go ahead and, you know, save some time when the time comes to do that. And so let me clean this up a little bit, and we'll go on to the Y-intercept. Okay, so Y-intercept, we have this business of, and I'm going to do my work on the bottom here, is that I would go f of 0, and I would have a negative tangent. And this part, is it fair to say that this is, so I don't have to write it, this is going to 0 out if I plug it in 0. And so pi, tangent of pi over 4, which I know tangent of pi over 4 is going to be 1, and so that's going to be a negative 1. And so it looks like our Y-intercept is going to be a negative 1 over here. So I'd have a 0, negative 1. Okay. For the domain, just like we did, we got all real numbers except x equals, and we take the first positive asymptote, which is going to be pi over 6. And then we're going to lift off that 2/3 pi from the last part that we did for the x-intercepts. And so we'd have, the domain is all real numbers except pi over 6 plus 2/3 pi, n, where n is an integer. And this time and I'm just going to leave it like that. And then the range, we know, is going to be a negative infinity to a positive infinity because of the nature of tangent, okay? You can't plug everything you want into the tangent, but anything that you want, you can get out of tangent. So let's take a look at what we need to do. So it looks like I'm going over here, and just, I like to go where I have the most information to start with this business of just trying to get the graph nicely portioned out. And so it looks like I'm going here and here, so going through like this. Okay. Would be a legal move, and again, we're doing that because it is flipped and regular, and so we're just sketching it the best that we can. Like that. And going on through of this sort. So from this guy, it looks like we're going to have to go down there and up here. So just using patterns to finish everything out. So that's how you do that. And we're going to reset ourselves for the next video and take a look at cotangent. And it's basically the same thing, except we start a little bit different. So that's how you do that. And see you in the cotangent video.